Hello, today we're going to be solving a physics problem. This is a two-part problem. The first part says, using blocks, books, dominoes, cards, coins, or any other set of identical objects, construct a stack that extends from the edge of the table. For a given number of objects, what arrangement gives the maximum overhang? Suppose that the objects are dominoes with a length L. How many are needed to a given overhang of L? How about 3L? The second part of the problem says, with a full set of 28 dominoes, build an arch that spans the space between two tables with identical heights. What arrangement gives the maximum span? Well, let's tackle out this problem. So for this small example, I have a domino, and this black mark is a center line. So I'm going to see how far I could extend that out without the domino falling off. So it's about center halfway now. You see right here, it's a little small gap opening. So this is probably the most I could push the domino, extend it out without it falling. So I'll push it out just a little bit more. It's gonna fall. So for one domino, it'll be approximately halfway point or halfway point. So let's try a second domino. So here's the second domino. Now, if I just lay it on top of the first domino that's halfway, let's see what happens. It's not gonna work, so let's see what I could do. So I might need to move the format. This domino might have to be probably 3/4 of the way or something for the second domino to extend out and not fall off as well. So probably a little bit of 3/4 of the way, and then they fall. Let me try one more. So this is probably 3/4 of the way. So the question is there some type of equation we could use to determine how many we need to balance out each domino for each additional domino that we include? Well, let's find out. So for this example, we're going to be using dominoes. It's easy to see what's going on with these because they're small. So if we were to stack one domino off an edge, the farthest we can place it out on the edge without falling off would be halfway point, or half the size of the domino, as we've seen in the first video that I showed you. So here's just a simple drawing. Let's pretend this equal ground, no incline or nothing, and this domino would be approximately halfway point. So we are going to be applying the harmonic series, specifically the sum of harmonic sequence, which is this equation here at the top. Now it seems pretty long at first, but it's actually not. It's really simple. Here we have 1 over n, where n is the number of dominoes, and since in this case we only have one domino, we will divide by 2. So we have one domino, it would be 1 over 2, which is 0.50. So our max overhang would be 1/2 or 0.50 for the first domino, and anything more than that, then the domino would fall off the edge. So if we were to place another domino for a total of 2 dominoes, then we would not place them in the same placement as the first domino. Instead, we would have to find a center of mass so that they don't fall off. In this case, we place the dominoes each roughly 3/4 apart from each other, stacked. So assuming this is a domino, first domino, second domino, we're going to have to move the placement of them. So our sum of harmonic sequence formula will now become 1 over 2. So since we have 2 dominoes, since n is the number of dominoes and we have 2 dominoes, it's going to be 1 over 2. And this gives us 3/4 or 0.75%. So these values, 0.50 for the first domino, halfway, and 3/4 for the second domino, it correlates with the example that I showed you in the first video, where with each additional domino, we need to change the placement of the domino at the bottom. And so for the second domino, our max overhang now would be 3/4 or 0.75. So adding a third domino, we would need to change the placement once again of the domino so that they don't fall over. So again, just imagine this is a third domino. And so since it's our third domino, we're going to have 1 over 3. where n is the number of dominoes. 1 over 2 plus 1 over 3. 3 is the number of dominoes. And so adding the sum of harmonic equation to find the maximum overhang, since we have 3 dominoes now, we would write it as this. And we would get 11 over 12, which in decimal form would be 0.916 repeating. So repeating the process again for the first domino, it would be as this. Since this first domino would be 1 over 4 divided by 2, and we would get 25 over 24, or in decimal form it would be 1.0416 repeating. So I'm sure you guys got the gist of it now. We follow the formula, which is here on top, and for the number of dominoes we put it as n on the fraction. Since our value now is above 1.00 or higher, this is a complete overhang. So with the first domino, we achieved the overhang of 1L over 1. And so to find the overhang, where the value would be 2 or 2L, we would need a total of 31 dominoes. So here's a quick calculation. 1 plus 1/2. And since it's 31 dominoes, we're going to put 1 over 31. And all of it divided by 2. And once you do all the calculations, it would be 2.1362259. So if we use 30 dominoes, it would not be 2. It would actually be 1.99 something. So if you don't believe me, well, let me show you. Adding the 31st domino would give us a value of 2.01362259.772. So coming back, to achieve an overhang of 3L or 3.00, we would need approximately 227 dominoes. And so we will write it as this, our equation. And repeat all the way until you reach 227 dominoes divided by 2. And this will give you a value above 3.00 or 3L overhang, and so forth. So if you wanted to find the overhang for 3L, of which the value would be 3.00 or above, we would need approximately 227 dominoes. And so this answers the first part of the equation. Suppose that the objects are dominoes with the length L. How many are needed to give an overhang of L, and how many to give an overhang of 3L? Well, here we go. We need 4 dominoes to have 1L. We need 31 dominoes to achieve an overhang of 2L, and 227 dominoes to achieve an overhang of 3L. So all this, of course, is theoretical. For instance, if we were to try this in real life, just even the slightest incline on the ground floor may interfere with our calculations. So, utilizing the law of harmonic series, we saw that the first domino could only extend halfway point, and anything above that, it would cause the domino to fall off. So this is our halfway point, this black mark, and that's as far as it could extend before it falls off. This is our halfway point right here. Any additional touch to go past 0.50, it would fall off. So according to our equation again, with the second domino, the most we could extend it out is 3/4. So let's try to find it out. So we found this is approximately 3/4, and voila, it works. And so for our second part of the problem, it says, with a full set of 28 dominoes, build an arch that spans the space between 2 tables with identical heights. What arrangement gives the maximum span? Well, let's find out. So for our second part of the experiment, it says, with a full set of 28 dominoes, build an arch that spans the space between 2 tables with identical heights. What arrangement gives the maximum span? Well, this is the best that I could provide for this experiment. The best that I found was this one, the eighth type. And so I understand that this provides more of a span, but when I tried it, it just would not work with 28 dominoes. So this is the reason why this arrangement is the one that works best for me. And so the distance that I could get the most was approximately 2.5 inches. So thank you, and I hope you enjoyed this experiment.